Yeah. Hi everyone. Thanks for having me. Let me just get my screen shared for you. Cool. I believe you all can see me. So we're going to be talking about how to run rm minus rf slash on your servers and just get rid of like all the servers that you have and just going serverless. Not really. You should never run this on any of your computers or any of your friends' computers or anywhere. That just don't. But yeah, thank you for the intro. My name is Marcus Placona. I am a developer evangelist for a company called Twilio. I imagine some of you will know Twilio already. If you don't know Twilio, Twilio is a communications API that helps developers like yourselves adding things like SMS messages, voice like telephone calls, chat, video, emails, anything to do with communications into the applications that you're already building using the languages and the programming languages that you already know. That's kind of like the beauty of it. Twilio itself also has a serverless solution. I'm not going to talk about the serverless solution from Twilio today, mainly because I want to talk about Kotlin here. So the serverless solution for Twilio doesn't really run any JVM stuff right now, which is good. It's like I don't really want to go talk about that. There's some information on the screen about me as well. So there's obviously my Twitter account. There's my GitHub. So a lot of the code that you will see here today, it's is on my GitHub account. I run a website called AndroidThings.rocks. I'm going to talk a little bit about Android Things at the very end of this presentation. And I also run realkotlin.com. Realkotlin.com is like a website with like very sweet and short snippets for Kotlin code. I am primarily an Android developer, so a lot of the things that you will see here, they will be sorts of like they will be serverless, sorts of targeted to Android developers. So hopefully, if you're an Android developer, you will get some stuff here today. But let me tell you about serverless, which is like a hotness that kind of gets rid of all your servers. I want to tell you about what that actually means. Okay, I want to tell you about like what does it mean to run Kotlin on a serverless environment. I don't know how many of you have run Kotlin on a serverless environment or like, have even run Kotlin on a server. I think until my only experience with Kotlin so far has been on serverless environments. Like I haven't got Kotlin running on servers or anything like that. And I wanted to tell you a little bit about this experience, okay? But let's just start from the very beginning here, and let's just think about what is serverless really. So what does that actually mean? So someone very very smart on the internet, you may recognize this name. This very smart man, Martin Fowler, said serverless architectures refer to applications that significantly depend on third-party servers or on custom codes that's run in ephemeral containers. Now, that's a bit of a mouthful. Like when I read this, I'm not really sure I understand what serverless actually is. Okay. Now, one way I found to actually describe this, which is the way I describe today, and the way like I found this on the internet, so obviously it must be true, is serverless is using someone else's Kubernetes cluster. And I think that's a really, really good description of serverless because now what it means is you don't need to have all those servers. You don't need to have all those things that you pay for and that are like idle most of the time because, if you have an API, for example, there are going to be times when your API is not requested, so your servers are idle. You don't need any of that. You basically just have someone else you have someone else have a server, and that person basically takes care of everything. So serverless is like the serverless is only serverless for you. Okay, there's someone taking care of those servers. I'll tell you that. It's only serverless for you, but it basically takes away the whole like having to take care of an application. So one of the things with serverless is like no ops. Okay, so I don't know how many of you have built applications before, but you will know that doing ops for applications like backend applications is a pain. So imagine, let's just think about an example here. Like imagine you had a Python service, and then that Python service, for some reason, it's a backend. It communicates with a Node.js on the front end, and then you use something like Redis for caching. Then maybe you want to use some MongoDB for a database, and then you have an Android application that kind of like reads all this information. Like it just tries and use your API. And if you've never done something like this, if you were to use Docker, for example, your Docker Compose would look something similar to this. Okay, so like you've got your services, you've got like your service, which is in this case is Vos, and you've got your results that's running Node.js. Then you have your worker, which might be doing something with that data, and that gets long very, very quickly. Okay, because now we have a Redis instance, we have a database. In this case, we're using Postgres, so it's a lot. And the thing for me is like, while I was writing all this code, I wasn't actually doing any of the codes that I actually enjoy doing. Like I wasn't actually writing any Android code. I wasn't actually writing any JVM codes. I wasn't writing Kotlin here. And this is the thing that bothers me so much here. Because like I have this configuration file that I had to, like I now have to maintain this as well. Because if you notice, there's versions in here. Like this is using Postgres 9.4. What happens when Postgres 10 or like whatever, I don't know if that even exists, but like what happens if Postgres 10 kind of comes out now? What do you do? Like, do you go change that file? What do you do? So you also need to have an understanding of how Docker works. And what if I told you that you don't need anything? What if I told you that you don't need any of those things? And in reality, you could get most of the stuff that you want for free. Let me just clarify, it's not really free. Okay, like I like saying it's free because a lot of these services, they have a tier that is actually very generous. Like they actually let you do, and they let you get away with a lot of free stuff. But it's not necessarily free. Okay, it's not 100% free. But let's look at some examples, and let's look at some prices. I'm using this website called Serverless Calc. And what Serverless Calc does is you can pass a number of requests that you want to make. You can choose like the execution time. So I put my execution time as 500 milliseconds. That's half a second. So it's not bad for like a serverless function. Like you shouldn't have serverless functions that go for like too long. Because you're looking at not paying too much money here. Like the longer they increase, the more money you pay. And I'm looking at 128 meg. And remember, like we're talking about one thing, okay? We're talking about one specific usage here. Like this is one function that does one thing. You can have as many functions as you want. I wanted to include all the ones with free tiers, and I wanted to be able to make HTTP requests. So it's important for me to be able to make HTTP requests because I want to use them for my Android application. So I'm looking at 1 million. In case you can't make out this number, this is 1 million. So if I want to make 1 million requests, I can basically make those 1 million requests for free. Okay, I can be using AWS Lambda, I can be using Azure Functions, Google Cloud Functions, IBM OpenWhisk. I can be using any of those things, and I can do that for free, which is kind of amazing for me. I'm just kind of like zooming in a little bit on the prices because I'm always kind of slightly amazed by this. Like I can do those things for free. Like again, 1 million for free. Okay, now we talked about free. Hey, why did I keep saying 1 million so many times? Because yes, 1 million is basically the sorts of like where where you kind of like jump off the fence and now you start paying a little bit more. I'm going to show you how much you pay as well, so don't worry about it. So it's not necessarily free, but it's cheap. It's cheap because you're billed by the milliseconds as opposed to being billed by the hour. We're going to talk a little bit about this later as well. Like, what does that mean, being billed by the milliseconds as opposed to being billed by the hour? Let's just look at this example again, because I want to, like, I obviously told you that 1 million requests are free. 7 million requests in this case, they're obviously not free. So I'm saying anything above 5 million requests is when things start to get a bit more expensive. Again, I say expensive. It's like it's not that expensive. We're still looking at like AWS Lambda at $22. We're looking at Azure Functions at $1.20. We're looking at IBM OpenWhisk still free at 7 million requests. And we're looking at Google Cloud Functions at $2. Obviously, you have your compute costs as well. So if you look at IBM OpenWhisk, for example, you're still paying 64 cents for 7 million requests, which honestly, I'm I'm okay with this. But the most important thing for me here is like this is all under $25. Like even on AWS Lambda, which seems to be the most expensive here, this is all under $25, and that's great. Like I can make 7 million requests, and I'm okay with making 7 million requests to run something that is like critical to my business and only paying $22 a month, for example. I am very much okay with that. Now, we talked about being billed by the milliseconds as opposed to being billed by the hour or being billed by the day or something. So let's just look at an example of what I mean here. Let's say you have a scheduled task here, and this scheduled task, it runs every minute. So imagine this is a scheduled task that runs for like 500 milliseconds as well, okay? And it runs every 10 minutes. It executes code. Let's say it's being particularly slow today, and like I've made some changes to my code, and it's executing code every 10 minutes, and it executes code for 10 minutes, okay? Now, what happens here is I am still being billed for the 9 minutes in which my server was idle. Like my server was doing nothing. I have this scheduled task somewhere, and my server was basically just doing nothing because like it doesn't do anything for the other 9 minutes. I am being billed by this, okay, and this is the issue that serverless actually tries to solve. Like I don't know about you, but I am definitely not in a place right now where like I definitely don't ever want to be in a place where it's like I'm just making it rain. There's all these dollars coming down. Like I definitely don't want to be there. Okay, like if I can save money, I will save money. If I can be as smart with the way money, I am definitely going to try and be smart with it. Okay. I am just kind of keeping an eye on any of the questions that you may have here. Feel free to put your questions on the chat if you have any questions. But we are here to talk about serverless, and we are here to talk about Kotlin. Okay, so I want to get a bit more serious here. I feel like I've given you the landscape. I've given you like what the landscape actually is, and now I want to make sure that we are getting serious here and that we are talking about Kotlin. So what is important to me when I build an application, when I build something? What is important to me? The important things to me are I want something that runs on the JVM. The JVM is where I'm comfortable with. Okay, like I'm comfortable writing Kotlin code. I am moderately comfortable writing Java code, although I'm always going to choose Kotlin there. But I want something that runs on the JVM because I know Kotlin, you can obviously we saw this morning, like you can compile to JavaScript and everything. I am comfortable debugging on the JVM. This is the environment I'm comfortable with. So I want a serverless environment that actually gives me the JVM. I also want it to be accessible via HTTP. Like I said, most of the applications I build, they're built for Android, and I want to be able to call my serverless function via HTTP from Android and get a response back if it needs a response. It needs to have a generous tier for testing. Like I don't mind paying money here if I have to pay money, but when I'm testing, I'd rather not pay money. Like especially if this is a new product, if this is a new thing, I'd rather not spend money. And I want something that has a generous tier. I want something that is non-intrusive to my code. I feel like this is probably it's almost like my number one. If I were to rank, like these are not ranked in any order of importance, but if I were to rank, I would probably say non-intrusive to my code is very important, and there's a reason why I'm saying this, and we're going to look at that in one of the examples. I want something that is quick to deploy as well. Okay, we have an example here of something that is not quick to deploy. Having a CLI is a plus, okay? Like having a way for me to do stuff on the command line from within my IDE. I actually use a command line within my IDE quite a lot when I'm building. I want, having a CLI is a plus because I can basically never leave my IDE. I can write my codes, I can deploy, I can build my packages, I can deploy, and I never need to go and like drag and drop a package from a place to the other. So keeping that in mind, what I have that is important to me, like keeping all those 6 things in mind, I ended up with 6 products. Okay. The reason I don't have Microsoft Azure in here is first, for me, it didn't really feel very natural building JVM applications inside Microsoft Azure because of their tooling. All of the examples I saw for Microsoft Azure, they say, oh yeah, now open Visual Studio Code and create your code. I don't want to do those things in Visual Studio Code. I wanna build my application using IntelliJ. So what I ended up with is I have Google App Engine, which is part of the Google Cloud platform. I have Apache OpenWhisk. The cool thing about Apache OpenWhisk is Apache OpenWhisk is obviously open source. In this case, we're going to be using Apache OpenWhisk on IBM. And we have AWS Lambda, which is the Amazon option. So you basically have like the sorts of like the biggest options in here. So you have Google, IBM, and Amazon as your serverless containers. So I wanna look at a demo for each one of them, and I'm gonna start with OpenWhisk, okay? And the reason I decided to start with OpenWhisk is like I have to say, when I first looked at OpenWhisk on IBM, I was like, I'm not really sure about this, but I actually really like OpenWhisk as a platform. There's like a very, very wide community behind OpenWhisk. And instead of leaving my presentation, I usually just do this on the IDE, okay? But because we're doing this via video and I have no way of like actually getting feedback on what you're seeing, I decided to just bring my IDE into my slides. So I have this application here, which like you can see, it's a build.gradle. This is a Kotlin JVM application. There's nothing special in it. Like this, I haven't done anything special other than just adding some dependencies. All of my dependencies, they are dependencies that my code uses, as opposed to dependencies that I will need when I go live with this. And again, this is really important to me. Like, I don't want to have to change my code because I'm deploying to some different vendor. Like, I want to be able to use the same code as I would run locally, for example. Then I have my main file. This is my main class. And my main class doesn't do much other than just returning some JSON objects. It returns a message. So it takes a JSON object as an argument. In this case, it takes a name, and it returns a JSON object with a message saying hello name. So in my case, it would say hello Marcus, but we'll look at this in a second. Now, the thing I'm going to do is I'm going to create a jar out of this. So I have made some changes to my build.gradle, and basically what it does now, it just like creates a jar. It creates a jar file for me that goes under libs and everything. So it goes where jar files usually go. The next thing that I'm going to do is I'm going to go into my terminal, and I'm going to use the bxwsk. So this is basically OpenWhisk command to create a project. So I'm just saying, hey, here's a jar file. So imagine like Marcus is getting the jar file and dragging and dropping into an interface. Like, I'm not doing this manually. I'm just doing this via my IDE, just using the CLI. I only installed the CLI. Now, that's it. Like, I have an application that runs and I have deployed it. If I wanted to make a request to this application, I can make a request to this application by just running it with bxwsk action, and I can even make an HTTP post into this application. The HTTP post basically just returns hello Marcus. I pass the name and it returns my message saying hello Marcus, and that's it. And the beauty of this is I didn't write code in any specific way so it runs on OpenWhisk. Like, I didn't have to change my code to be in any specific format so it runs in OpenWhisk. And I feel like this is very, very powerful to me. So if we look at the pros, for example, we will see that some of the pros are, it doesn't care about what you're building. Okay, so like OpenWhisk doesn't care about like what kind of application you're building, as long as this is a JVM application. In my case, I'm deploying JVM applications. You can deploy other things in OpenWhisk as well. I haven't tried this. I only tried Kotlin applications. It doesn't care. It doesn't have any vendor dependencies. Again, it doesn't add any sorts of like craft into my code, and I have to say I really appreciate that because I don't want to have anything in my code. The other thing is that is a con for me is like the documents are very, very, very fragmented. Like documents are basically all over the place. So just like like I said, you have open whisk stuff, and you have IBM stuff, and the documents are very fragmented. Like there's documentation everywhere. Okay, it's not too hard to get started once you find your way in. It's not too hard. Obviously, you're probably looking at like building some kind of like workflow for yourself. And when you build a workflow, it's very easy. Pricing, like I said, this is free up to 6 million requests. When you get 7 million requests, you're going to pay a little bit more. But this is free up to 6 million requests, which is amazing for me. Okay. Now, how about Google? How about the Google App Engine? Is it good? Is it not good? So I'm gonna show you a demo here of the Google Cloud Platform, and I felt like I wanted to show you a much better demo, but I just couldn't get myself to use it because I had to make so many changes to my code. I had to look at so many documentation. There's a lot of documentation that is like, all over the place. And but let's look at this. Let's look at experience. And for this one specifically, I wanted to have a timer because I wanted to show you how long it takes for me to, like, from the time that I build an application to the time when I try and deploy and the time I try to use it. So I have a stopwatch here. So I just Googled for stopwatch, and I have a stopwatch which I'll start and I'll build my application. Okay, so I'm gonna go Gradle build, and I will build my application. Builds really quickly, same application, nothing special in here. Then I call gcloud functions deploy, and then I try and deploy this, and it's gonna say, well, yeah, it may take up to 2 minutes. Like the first time I saw it may take up to 2 minutes, I was like, oh, okay, so that is not as quick as the IBM option, but I'll stay with this. And then I saw that timer moving and moving and moving, and nothing was happening. So that's me basically speeding up time for you, okay? Because this keeps going for a long time. Obviously, as you can see, it keeps going for longer than 2 minutes. And it goes, and then you get a operation error. And what bothers me so much about this is, hey, I could be doing something wrong here. Like, I don't think I am, but like what bothers me so much about this is it says, error setting up the execution environments for your function. Please try deploying again after a few minutes. What does that even mean? Try deploying after a few. So if I try in a few minutes, it's going to work. But then next time I'm trying to deploy something, maybe it won't. Like it only works. Like, does this thing only work in leap minutes or something? So I found that documentation for Google App Engine was not great, okay? And I found that like the whole experience with like changing my code so much was not amazing. So I gave up on it. I'll be honest with you. I gave up because I couldn't find decent documentation. I couldn't find anyone. I asked a question on Stack Overflow, and the first answer I had was, "Why are you using App Engine?" So I gave up. I used something else. But I'll give you a pro. If you're already on that platform, like if you're already using GCP, like if you're already using the Google Cloud Platform, then maybe there's a point here in saying, hey, I'm gonna like pursue these. Like I'm gonna try and be a bit more. I'll try and make this work. I didn't have the energy of trying to make this work. And your code is also locked to that platform because this thing riddles your code with a bunch of like different dependencies and everything. Your code is not, your code is written specifically for this. So if you were using Google Cloud Platform and suddenly, specifically for App Engine, and suddenly you decided to move to like Lambda, for example, you would have a hard time because you would need to go and change your code. And that doesn't sit well with me. In terms of pricing, the pricing for this is like you pay per instance. It's not it's not more expensive, but you just pay per instance. You don't pay per per milliseconds. And a caveat is like this is a bit of an unfair comparison because like the Firebase Cloud does that too. So that's the other side of it. It's like there seems to be 3 or 4 options in which I can do serverless with the Google Cloud platform. And like upon like trying a lot with using Google App Engine, someone said, "Oh yeah, you should try using the Firebase Cloud," and it's like, "Oh, what's the difference?" Like I don't. Again, that's the kind of stuff that I don't want to care about. I want to go and deploy somewhere. Like I don't want to care about it's like, oh yeah, this is the service and I need to configure this service in such and such way. Like there's an app.yaml that you need to add into your Google App Engine. So there's like files that you need to add into your project. And I don't want to have to deal with that because I want to deal with my environment. I want to deal with the thing that solves my business problem, as opposed to deal with things that make it easier to deploy. But that's a personal preference. Okay, so obviously there's a chance here that you may have used it and you're having like the best time of your life, and I'm okay with that too. I didn't have a good experience there. Now let's move on to just me telling you a story. Like usually I bring some props when I tell you that story. I move around a little bit. Obviously you can't see that, but I move around a little bit. I show you some of the props that I brought and everything. I try and make this like as interactive as I can. I'm gonna try and portray that story for you right now, and hopefully you'll be able to feel the way I feel. So obviously I work from home now. I've been working from home for 5 years. So like working from home is not a new thing for me. But when I work from home, I look pretty much like this. Okay, maybe with different headphones and a different hair, but I look pretty much like this. I'm listening to music the entire time. Okay, and I'm listening to loud music. I can't listen to very loud music right now because I'm not the only one working from home, but usually I listen to very loud music. And that's kind of like how I do my work. That's how I can be productive. And what happens usually is the postman just comes over. Like I live in England, as you can see, so this is what all postmen look like. The postman knocks on my door, and they have a parcel for me. But obviously, remember, I was like this. Okay, so I'm still pretty much like this. So postman's knocking on my door. Postman's like smashing my door, and I can't hear it because I'm listening to my music. And that's what the postman looks like. Okay, because obviously now the postman is trying to deliver something to me. They're on a schedule. Like, you know, maybe they have something that doesn't go through the letterbox. Now they need to leave me a note and everything, and I'll need to go pick it up and all. And like it's a pain for the postman, and it's a pain for me as well because they leave me a note. Now I need to go pick up something somewhere at a depot or something. Whereas like, you know, maybe there's something that I can do to kind of like change that situation, because I always have this is not what my phone looks like. Okay, I literally just Googled like phone, and this is what I had. But basically, I always have my phone in front. Oh, I think this is a Nexus 5. I always have my phone in front of me. Okay, and by always having my phone, it means I could be, you know, if I miss every doorbell, but I don't miss any phone calls because like my phone is literally in front of me. Like it kind of glows when someone rings me. So it's always in front of me. So I maybe I could do something with that. Maybe I could use that. I'm not just about to tell you that I gave the postman my phone number. Okay, this is not it. What I'm about to tell you is I decided to change the way my doorbell works. So when the postman rings my doorbell, my phone also rings. And I actually wrote something about this. This was a while ago, like this was a few years back, and I wrote how to do it. So like the idea here is like you make a change to your existing doorbell, and by making that change to your existing doorbell, now your phone also rings. I obviously used Twilio for that. I used Android things back in the day, so I know I said I run Android things.rocks. Android things is no more. Like it doesn't really exist the same way that it used to exist back then. But this is like all the stuff that I did here, all the IoT stuff that I did here is like very, very easily replaceable for something like an Arduino, for example. I think the important thing in here and the important message is I wrote all this application using AWS Lambda. And the reason I did with AWS Lambda as opposed to something else is I just wanted to see if AWS Lambda was going to work well for me. It worked well. Again, remember, AWS Lambda, I think it has a limitation of 1 million requests. 1 million requests is absolutely okay for your doorbell. I do not expect people to ring my doorbell over 1 million times a month. I hope not. And if they do, I'm probably doing something wrong. Now, the pros with this is a lot of people already use AWS, okay? So like if I ever got stuck with anything with like deploying to AWS, it's very easy to troubleshoot. Like as soon as you go into Stack Overflow and you ask a question about AWS, there's like 1,000,001 people who will like just help you troubleshooting. The AWS terminal is very hard to navigate, so like people help with that too. The other thing about AWS Lambda is like you have no vendor dependencies, like your Kotlin code doesn't change, your dependencies don't change. They have a comprehensive API console. Like there's like way more than you need on their API console. Like there's way more than I needed on their API console, but it's very comprehensive. Like you kind of want to have as much functionality as you can. Okay, like you want to have that available to you even if you don't use. Cons is like as everything that Amazon does, the documentation is all over the place. Like there's documentation from 6 years ago, there's documentation from 6 months ago, and neither of them work. So the documentation is very much like all over the place. The free tier is not as generous. It's definitely not as generous like as 6 million requests, for example. And you can't really invoke Lambdas directly via HCP. Okay, so you create your Lambda function, and now you need to create an API endpoint for your Lambda function. So you can like invoke your Lambda if you want, but you can't invoke them via HCP. You need to go into the console and you need to create an API endpoint. After creating this API endpoint, you need to say, okay, so this API, say for example, /doorbell calls that specific function. It's not hard, it's just something else that you need to do. I found that you can do that via the CLI as well. Doing that via the CLI is not as easy. I found that doing it with the API console was way easier, but then this takes me away from the IDE. Now, in terms of pricing, like I said, this is free for up to 1 million requests. Like you pay nothing for up to 1 million requests. And again, like I said, million requests is more than enough for my doorbell. I have that. I have Lambda functions working with a smart, like a dash, but like an Amazon Dash button. It's the irony of like using Amazon Dash and Lambda functions, and it's like it's free for up to 1 million requests. So it works well. It's quick. But the documents are kind of bad. Okay, like I have used a lot of like Amazon APIs in the past, and it's just something that they haven't been able to fix ever. Like I think they write a lot of documentation, but the docs are bad. Whereas the beauty of using something like OpenWhisk, for example, is the docs on the IBM side, they're not great, but there's a massive community behind it, and it's open source, so you can go and look at the code. And it's kind of beautiful that it works this way. I just wanted to kind of like finish off this by saying serverless is really not the future. Okay, like serverless is happening right now. It's not the future. Like if you're still like if you still have like your Rackspace server or something, it might be a good time to think about like maybe moving to some serverless functions. It also may be a good time to think about like why you have those servers. I realized that a lot of the functionalities I had on my application that came from APIs, I could just turn them into serverless functions and they would work just as well. You can use things like, if you want to, you can use things like Spring, you can use Ktor, you can use Micronode. Excuse me. You can use Micronode. So you can use a lot of stuff. Like you can use a lot of frameworks for building your serverless applications. And again, the beauty of it is like you want to try and not have anything that changes your code too much. So you want to build your codes the way you want, as opposed to the way, I don't know, like the way a vendor wants. Like I don't want to pick on any vendor, okay? But like you want to build the way you want, as opposed to the way a vendor wants. And with that, that's the end of my presentation. If there are any questions, I'm going to try and look at the chat. Like this is really weird. It's like I can't see any of your reactions or anything. So I'm going to try and look at the chats and see if there's any questions that I can answer. My information is here. So like I am Marcus Placona. I am a developer evangelist at Twilio, and I will be around. I will be here in case you want to ask me any questions afterwards. Like if you want to ask me questions outside of this, it's absolutely fine. There's my Twitter information in there. There is my GitHub. You can see all my code. I will be publishing the slides later on. So if you wanna get my slides later, I'll be publishing the slides. And thank you very much for having me. Thank you very much, Kotliners, for having me as well. It's been like this has been a really, really good experience. I have really, really enjoyed the conference so far, and I am gonna be right here. Thank you. I'm gonna try look at the chat. I don't seem to have any questions. I see some people logging in, but I don't seem to have any questions. Let me try going to the conference page. All right, I'm just logging in. Cool. Okay, so someone's saying, well, I was thinking about using Google Cloud, so thanks. The Firebase Analytics APM, which is the New Relic. Yes, New Relic is a bit expensive. I haven't used New Relic myself. I have used the Firebase clouds. I have used Firebase Analytics, and that's really, really cool. There's someone asking about the JVM start times compared between AWS, Google Cloud, and OpenWhisk. I noticed that I'm gonna call that the code start from OpenWhisk is quicker than anything else that I've seen. Okay, like you're still like starting a JVM, like you're still starting an application, but it's quicker than anything else that I've seen. So if I were to put them like stack rank them, I would say OpenWhisk, AWS, Google Cloud Platform. Like Google Cloud Platform was like by far the slowest on doing anything, but Firebase Analytics is good. Are there any disadvantages with serverless in your experience? I'd say the disadvantages, if you have a very big service, then that could be a disadvantage because I found that debugging serverless applications is hard, and I found that the heavier they are, the slowest it is for the sorts of like code startup. Someone asked if I tried Kotlin. I haven't tried Kotlin. Have you tried, Anton? Have you tried Kotlin? Like, what do you have to say about it? I have not tried that myself. There's someone saying, Michael saying JVM startup time is the main reason why I stayed away from the JVM in Lambdas. Do you have any points to decrease that? So one thing that I've used that was really interesting, like obviously you can configure the memory for your instance. Obviously adding more memory make things slightly quicker, even on the startup, because basically, when you think about a JVM application, you're saying you can use that much memory. So if you have more memory in your function, like if you say, for example, I'm going to pay for like a gig of memory, your JVM is going to start up quicker. I have not tried GraalVM, but I will say one framework that I tried that I really, really like is Micronaut. Micronaut is like, I think it's probably what the Python people would compare like Django and Flask, for example. So Micronauts is a lightweight framework, but I tried that and I really liked it because it is quick and it's very easy to get started too. In your experience, is likely that the cost for serverless setup exceeds the cost of provision instances? I haven't seen that, Jan. In my experience, serverless always worked out cheaper for me. Like it was always. I have some instances as well. Oh, someone really likes Micronauts. Yeah, cool. I have some instances as well for other things. I have used Heroku a lot for like Heroku is a good example of like having an instance, and like my Heroku costs more than anything that I do with serverless architecture. Okay, by far. I have reasons why I use Heroku, but it costs like more than anything else that I have paid in serverless. And do we have any more questions? Any more last minute questions? I think we have 3 minutes to go still. So if you have any pressing question, now is the time. You can always ask me later too. All right. Thank you very much again. Thank you so much for all the questions. I am gonna be, so if you have any questions afterwards, feel free to ask me them. But thank you so much. Thank you so much for seeing me, and enjoy the rest of the conference.